Hey guys, welcome back for the Midweek Mentoring. I am really excited about today because we're still talking about a topic that's really fun and exciting for me, which is math, and especially 1 plus 1 does not equal 1, or even more specifically, 1 does not even equal 1. So last week we talked about how that's true with synergy and with leadership and in families, how 1 does not equal 1. And we also talked about how in ancient cultures like the Egyptians, the Hebrews, and the Greeks, because they had different meanings for 1, they weren't equal throughout, so 1 again didn't equal 1. This week we're going to take it a little bit to the next level by going into how even in modern science 1 does not always equal 1. It's interesting, in the language of modern science you have a lot of cool ideas and a lot of really great important principles, but when they come together you see again that powerful example of how, because 1 doesn't necessarily equal 1, 1 plus 1 can't automatically equal 2. So I'm going to start by reading a quote from this book, A Brief History of Time by Stephen Hawking. I'm going to read on page 12. By the way, if you don't know who this guy is, you should go look him up. He's a really cool guy. Anyways, page 12, it says, Today's scientists describe the universe in terms of 2 basic partial theories: the general theory of relativity and quantum mechanics. And by the way, if you don't know what those ideas are yet, for 1, it might be a fun time to go look them up and study them in a little bit more depth. And for 2, you can rest assured we're going to learn more about them later on. They are the great intellectual achievements of the first half of this century. And he wrote this in the year 1988, so he was referring up to the 20th century, not the 21st century. The general theory of relativity describes the force of gravity and the large-scale structure of the universe. That is, the structure on scales from only a few miles to as large as a million miles. Guys, he tells us here that that is a 1 with 24 zeros after it. So that's a lot of miles, right? Which is the size of the observable universe. Quantum mechanics, on the other hand, deals with phenomena on extremely small scales, such as millionth of an inch. Now this is where things get exciting. This is the real kicker of his comment. This is where everything gets turned on its head. Unfortunately, however, these 2 theories are known to be inconsistent with each other. They cannot both be correct. When he says that, your mind just, on the one hand, you're like, oh man, no, you can't say that. You can't throw modern science in the trash like that. But then the other part of you is kind of like, oh, because it shows us again how now I'm going to say this and it's going to sound really obvious out loud because that's what just happened in my mind. You have to actually think, right, for things to make sense. And that's important to know, and so often we want math and science to fall into that rote idea of this plus this, blah, 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 and it's just completely linear. It completely makes sense on the first try, and everything is just completely congruent and fits together nicely and is beautiful. And you know what? It's not that way, because it's an art and not just some distinct and perfectly categorized and all that. It's not a science in that way. It really is an art. That doesn't make it bad. That doesn't make it wrong. It just makes it an art. It just means that we have to think. We have to problem solve. Imagine that in mathematics, right? But it's not the problem solving of the rote idea of mathematics where your idea of problem solving is to go find the one right answer, give it to us in the way we want it, don't ask questions, don't complain, and don't argue because this is how it's done and that's the end. No, it's the true side of problem solving. It's like the leadership problem solving where you have to look and find an actual problem, and then you have to use your ingenuity, you have to use your mind, you have to use that creativity, and you have to work at it and fight for it and tenaciously keep going until you actually find a real, concrete, powerful, effective solution. To me, that's inspiring. That's exciting. That means mathematics is no longer some rote concept that comes from top down and I better just get in line. It really is an opportunity and a situation and a place where I get to really apply myself to things that actually matter, and to be able to learn and grow and develop at the same time that I'm actually simply understanding ideas that have already been learned and grown and developed by other people. So that's, to me, that's really exciting. Basically, the concept is the two main legs of modern science are mutually exclusive. In fact, maybe neither of them will turn out to be true. We don't really know, but we know for sure that if one of them's true, the other one isn't. And because we don't know for sure that either of them is true, we can kind of keep both of them. But at any point, if one of them is actually disproven, if one of them is actually proven, although you don't really prove things in math and science, right? You try to disprove them, right? But we can know that because of what they are and because of the details behind, again, you'll learn more about that as you study into it, but because of the details of these theories, they can't both be true. So, in quantum mechanics, 1 may equal 1. And in the general theory of relativity, 1 may equal 1. But even if that's the case, even if 1 equals 1 here and 1 equals 1 here, all of a sudden, the 1 here can't possibly equal the 1 here, because if these two are equal, then they would both have to be true. And yet, or at least they could both be true, and we know that they can't. So that's just crazy exciting for me. It makes me think of the rhythmatist, where, you get these people who there's this power and the magic system is all in chalk and in geometry, right? So if you get one rhythmatist who goes over to the sidewalk and draws a line, they have drawn this line, and then the next rhythmatist comes and draws their line. Well, are those two lines equal? Well, it depends, right? Because did they draw it equally straight? Did they have the same exact equal length? Did they use the same thickness? Was their chalk the same? All of a sudden there's all of these different factors that come in, and it makes not just a little bit of difference, not even just a big difference, it makes all the difference. You're either equal or you're not, right? Equality is a pretty concrete idea. And so if things aren't equal, they're basically just not equal. You can't be, I guess technically you can be almost equal, but to be clear, almost equal is still not equal, right? And so I think when you get into things like that, it becomes obvious again. If the lines aren't equal in every single way, if every factor doesn't match up exactly, then 1 does not equal 1. Which I think always brings us back, of course, naturally in the progression and the flow of things, we always have to come at this point to the concept of comparing apples to oranges, right? This is one of the oldest, most, old hat ideas, cliches, if you will, about making comparisons, right? You can't compare apples to oranges. Now, why is that? Well, because obviously no one apple will ever equal any one orange, right? They're simply not, you can't compare them together because they're not the same, right? They do not equal each other. But that's where things get really exciting. Because let me ask you this, and Ian will talk more about this next week, but let's just throw it out here because, yeah, it's obvious when we think about it that no one apple is really equal to any one orange, right? But let me take it a step further because this is key. This is important in understanding this idea. Is any one apple really ever equal to any one other apple? No. So basically, this brings us down to a simple yet really powerful and exciting idea. Does 1 equal 1? Well, yeah, sometimes. But only, now this is going to be obvious, 1 equals 1 if and only if, when and only when, this 1 is actually equal to this 1, right? Now, I say that and you're like, well, duh, right? But that's the key, that's important. And the thing is, when we look at mathematics in a rote way, we miss that because we want to assume that every 1 is automatically equal to another 1. And as soon as that's true, okay, great, 1 equals 1. But you can't just take that step. You take that step because, frankly, learning the rules of mathematics from that starting point is actually really valuable. Learning the simple and even rote ideas of, your basic math, your multiplication, division, addition, subtraction, all these things, and then even getting more complicated where you go into more of the algebraic ideas, where you get into the geometry and all the math that follows. It's still valuable to learn that row idea, the step that leads from 1 = 1 and beyond. But the thing is, you can't miss that is a postulate. That's not a proven absolute truth of the universe. That's an idea that we can't prove true because, frankly, in reality, it's not only is it not always true, but it's actually untrue a lot more often than it is true, way more often 1 does not equal 1 than the very rare, almost occasional once in a blue moon times when 1 does equal 1, and so you can't miss that step. You have to understand that because the rules of math are valuable and actually can really help us in our lives, we're going to assume, for the sake of this art, for the sake of the science that we're trying to learn here, we're going to assume that yes, 1 = 1. But when we make that assumption, we have to remember that, statement that 1 = 1, in parentheses, if and when, and only if and only when it actually does, right? But now that your mind knows that, now that you understand that from a thinking, seeing, really leadership perspective, now you can go in and see 1 = 1. Now your mind already knows what that means. In my family, we call this the bubble top principle, right? It's really interesting because I don't know if you guys have ever seen those vans that they're just, they're a normal van, but then they have like this big old bubble top thing going on where they raise the roof on the inside. So like you can stand up on the inside of the van, even if you're not if you're really tall, right? But you can, when I was a kid, we could. And, it has this sort of bubble on the top. Now, I never realized that those existed until one day we went out and bought one as a family. My parents got one and that was our car. And then all of a sudden it was crazy how often we saw bubble tops driving through. We actually made it a game like, the slug bug game where you see a beetle bug or whatever and you slug your neighbor, oh, bug, and then you say the color. Well, we made a game like that for bubble tops because they all of a sudden, now we had never seen one in our lives. The secret is we probably had, but we just didn't notice. But now that we had understood this idea, that it was a named concept in our lives, we started to see it everywhere we went. And they were everywhere, man. But it went from being no bubble tops in the world to now they were everywhere. Now, take that a step further. My husband, Ian, calls this the Waterloo principle, taken from Les Miserables, where you go through, when you're reading Les Miserables, again, it's a huge book, right? But it's deep and it's powerful and it's exciting. But sometimes Hugo goes on these, it's like they're rants, except they're the opposite of rants because rants are usually super emotional and like angry or, sad or whatever they are. But these are like super unemotional. This is where Victor Hugo goes and he goes on this historical explanation and he tells you like 100 pages about this history that you're like, why does this have anything to do with the story of Jean Valjean on this journey and then of Cosette and, what does this have to do with the lives of the characters I'm reading about? Nothing. It has nothing to do with the plot. It has nothing to, but Victor Hugo takes you through those moments so that every time after, so you read this whole section on Waterloo and it's this great big history. And then later on, he can say the word Waterloo. And rather than just being a word that either has some indistinct sort of blurry meaning in the back of your mind because you've heard of it in other history books, or you don't care about it all, or you don't know, rather than any of those experiences, you read the word Waterloo from then on, and it means a lot to you, as if you had just been there, because you have for 100 pages, right? Or more. And so this is a powerful concept, and that's what we're trying to accomplish here with 1 doesn't equal 1. Guys, you're still going to see in math books that are still valuable, and we're going to encourage you to read them and study them and really learn the rules as they apply in that concept, because it really will help you in your education. But when you come across that word, Waterloo, we want you to know what it means. We want you to have been through that 100 pages of history on Waterloo that seemed like it had no place in where you were, because now when you see that, you can still go forward and learn the rules and have a powerful experience. When you see 1 equals 1, Or when you see, 1 plus 1 equals 2, 2 plus 2 equals 4, you can know, first of all, I'm learning the math rules as they apply here. But you will also instantly and immediately know in your mind, well, we're playing along because we're trying to learn here. We're leaders, and we know that our education isn't dependent on everybody thinking the same way we do or saying everything the right way every time. Okay, so we're still going to learn from these guys, but when we see that, you will know immediately, yes, 1 equals 1, but only when the 1 and the 1 are actually equal. And that's key. That's exciting. So, guys, keep learning, keep studying. Next week, Ian will give you the advanced, the real deep meat of this, and then it'll all become clear, and you'll really, really be ready to go out and study mathematics, knowing that, yes, 1 does equal 1, except when it doesn't. Have a great week, guys.